Hi, good afternoon, everyone. I am Edward. I'm the CEO of AINTU. So today is our second industrial talk. I would like to say thank you to Appier and Professor Lin for his strong support for this MLSS event. So it's our honor to invite Professor Shou-De Lin, representing Appier, to talk about machine learning as a service, challenges, and opportunities. Professor Lin has more than 20 years experience in AI, machine learning, and natural language processing. During his time in National Taiwan University, Professor Lin has received several Best Paper Awards in international conference. He received several prestigious research awards, including the Young Scholar Innovation Award in FAOS, Udayo Award in MOST. He also collaborated with more than 50 companies and also won, like in 2007, Google's Research Award, Microsoft Research Award for 3 times, and the IBM Research Awards, the AOA RD Research Grants Award for 5 times. He is also the all-time winner of the ACM KDD Cup, which he lead or co-lead the NTU team to win 7 championships. After joining Appier in year 2020, Professor Lin has led AIDO team to win the best overall AI-based analytics solution in 2020 Artificial Intelligence Breakthrough Awards. So it's great pleasure that we have a Professor Lin to have share the talk. So Professor Lin, so the stage is yours.
Thank you, Edward. Let me share my screen. Let's see where it is. Not finding. Let's do it one more time. Couldn't find my file. Let me see. Okay, good. Can you see me right now?
Yes.
Good, good. Thank you. So it's my great pleasure to be here to represent Appier to give this industrial talk on machine learning as a service. So today I'm going to share some of the experience and our works in this direction. My name is Shou-De Lin. So I will first use 5 minutes to introduce Appier before moving into the main thing of this talk. So Appier was founded in 2012 by the 3 co-founders, and there are several key recognitions we have received in these years. Okay, so Appier is basically backed by a strong machine learning scientist team and leading by Professor Min Sang from Tsinghua University and Professor Shentian Lin and myself, and also Dr. Li Fengjian is one of our key board members that has provided a lot of suggestion to the scientist team. And we are operating in 17 different regions, including Europe, North America, Great China, Northeast Asia, Southeast Asia, and right now we have about 500 employees worldwide. And Appier has been recognized as one of the leading companies in AI in the past years. And we have been devoted to build AI models and machine learning models for for MarTech. And in this year, and there's a good news that we have been listed as a listed company in Japan, starting in late March. So in Appier, we have this full funnel AI-powered solutions that allows our customer to utilize their data to make more profit on the advertisement side. And so from the lower bottom of the funnel, we can try to acquire or to obtain more attentions from our customers, and we have corresponding products to do that. Then we want to engage, and we want to bring more attention from our customers. In the second funnel, we have not only the predictive customer engagement solution, we also have conversational solution. And then we want to create some more opportunities for our clients to attract their customers to make a purchase. Then we have this ideal solution that's a self-served AI conversion booster. And finally, we have this cross-X solution that provides connection between different devices that empower the enrichment of the knowledge of the users and to build a data-driven solution. Okay, so then I will probably spend the rest of time talking about challenges and opportunities for machine learning as a service. So what's machine learning as a service? So if we provide a narrow definition, it could be for companies that provide machine learning tools as part of their cloud solutions or cloud services. For example, we all know that Amazon have this AWS machine learning and Google have its own machine learning cloud engine. In this talk, I'm going to offer even more general definition on machine learning as a service, which actually refers to all kinds of companies that design or customize machine learning models to continuously serve all their clients. And Appier is one of such companies. Okay, so before we enter in the core thing of machine learning as a service, I want to just simply remind you what we have learned in Machine Learning 101 from school. Okay, so normally to build a machine learning, we have this so-called machine learning life cycle. In the early stage, we need to gather all the data, do some preparation, cleansing, wrangling, and then we build a set of training data for model to learn from. And eventually, once the model are tested on a set of independent testing data, then we know that we are ready to deploy it for further usage. So in this scenario, like in class or in some competition like Kaggle, we usually are provided in the very beginning the training data, which is a bunch of instances with features and labels. And we are offered evaluation metric. That's how people judge how accurate or how good this model is. And then we offer a set of testing data, which are instances with only features but not labels. And we want to know if the trained model can perform well on this testing data. And finally, we are offered a certain period of time to build this model. And we need to finish this model building, training, testing before that time. And normally the goal is to find a model fx equals y that can create the best performance in predicting the labels in the testing data. Okay, so how this fits into the big thing of machine learning as a service. So in order to use machine learning to serve your customer, what I just mentioned, this training life cycle is only one component of it. So once you have this model, you have to put this model online for serving. And then once it starts to make prediction, then we can continuously gather all kinds of feedbacks from the users or from the target clients. And those by monitoring those results, we can further provide those outputs back to the model to either retrain or refine or completely rebuild from scratch. So in this big thing, there are a lot of things we need to be aware of. And let me first talk about data acquisition. So in the very beginning, we need to collect data to train the model, okay? And the training data, the quality of training data is usually far from perfect in real world. So it's very different from what we have learned in class, like somebody will prepare a set of so-called training data for you to build a model. And in the real world, those things have to be done by probably yourself or some relevant personnel. And so in this case, we have to be aware of that data sources are not perfect. Features can be missing. And in fact, in real world scenario, it's very likely you won't get completed features before training. And features can also contain error. Some of the data will probably, for example, obtained from the internet. And we all know that extracting information from internet, that we can introduce another level of error. Also, features can be coming from all kinds of free format sources and potentially very sparse. And to make things worse, the labels obtained for training are not perfect either. So on the right-hand side, I'm using these famous pictures to show why labels are not perfect. So depending on the structure of your brain, some people will can observe this picture as a dress of the color black and blue, but others might believe this is a golden and white dress. So this tells us like different people or different sources might offer you different labels for the same data set. And also labels can be missing. And so those things we need to be aware of and we need to take care of while we are trying to use machine learning to serve for our clients. And below, I also list some of the common popular models as a solution for part of the problems here. But to be aware of that, so this is still, we are still in the very beginning to solve all these problems. So a lot of research works are required to be done to fully resolve those issues. And furthermore, data collection itself, the process can contain bias. And those bias can be very hard to detect, but can cause very serious hurt. So next, I will introduce 3 different kinds of bias we have to be aware of while building a machine learning model as a service. First, called online serving bias. So this happens a lot for using a machine learning model to serve the customers online. And it's because like for training a model or updating the model, we usually use the data obtained from the model that's currently serving online. But the process of serving itself is biased. So take recommendation system as an example. So in this case, this model will probably recommend Harry Potter to many of the users because the model believes Harry Potter has higher chance to attract the user's attention. But this implies that we have more opportunities to obtain users' feedback on this movie Harry Potter comparing to the rest of the movies. So this introduced online serving biases, meaning that for the products they are less likely to be liked by a specific online survey model, will not get any chance to be tested or to obtain opinions from the users. So your model will less and less likely to recommend those items, and will focus on a diminishing set of a smaller set of items, and that's probably not always good for a model. And the second bias I'd like to remind you is the manual labeling bias. And so this bias comes from the fact that the distribution of the label data is not always identical to the distribution of the true data that we have observed. And so, for example, I'm taking this malicious URL detection model as an example. So if you want to build a classification model to detect the malicious URL, and very likely you will resort to some sort of resources that have already labeled those URL for you to train the model. And VarianceTotal is one of those sites that offers training labels, either malicious or benign, to the URLs. However, those data in VarianceTotal or any other kind of these services or database is not without bias. The way the VarianceTotal collect their data is usually like this. And somebody probably, when they surf on the internet, they found some suspicious URLs, and they don't know if it's malicious or not. So they submit to VarianceTotal. And VarianceTotal, they probably have some security expert to label those URL as benign or malicious. So once this process actually allows VarianceTotal to accumulate a lot of label data to train the model. But the problem is that the trivial URLs like apple.com, facebook.com, they won't be labeled in VarianceTotal because people, they already know they are good ones. They normally don't submit this kind of famous URL to VarianceTotal for checking. Okay, so if you are using this kind of database to train a model, it's very likely your machine learning malicious detection model won't be able to distinguish these very, very normal sites from the rest of the sites because you have never seen them in the training data. And the third one is usually we believe random sampling should be without bias, but actually it's not. Okay, so randomness in one dimension can lead to bias in other dimensions. And so I'm giving you an example. So for example, we are collecting users' preference through online questionnaires. So if we claim we are sampling user randomly, it seems very good without bias. But depending on the process of you build this random sampling procedure, it can still introduce bias. I will use two examples. One is we can randomly pick a set of online users during a certain period of time. So this seems to be very fair, but you will be biased on which time span you are using to do the sampling. So for example, if it's in summer and in winter, probably the behavior will be very different. If it's in the morning, during the working hours, or in the evening, during the resting hours, the behavior could be also very different. And another way to do random sampling is to sample a set of users in advance, and like even before everything starts, and ask them questions when they enter the website. Okay, so this kind of sampling will also introduce bias depending on how you obtain this initial set of users in advance. So there's a famous paradox called Bartrand paradox. So it tells us that there are a lot of different ways to randomly sample a code of a circle. And based on this different type of randomness, it's possible to obtain different probabilities, distributions of those chords. Okay, then I'd like to talk about evaluation. So we're building a machine learning, building whatever services, we always care about the evaluation, how we judge the quality of the machine learning model. And there's a paradox. It seems that once it's not observed by us, so it's normal because like the labels our customers really care about are usually hard to obtain for training. Okay, the objective for training are usually, like we know, like in machine learning, we need a lot of data for training. We need a lot of labels for training. But in a lot of applications, the true label or the label that customer cares can hardly be obtained, or their amount might not be sufficient to train the model. For example, in digital advertisement, so we really care about, or our client really care about, is the purchase. How much people purchase this set of items, because they gain the overall profit come from the purchase. But comparing to the other actions like click, view, put into cart, purchase is much sparse. So while training a machine learning model, usually we have to resort to using click, using in-cart, using view, and instead of using purchases to train the model. And this creates a gap because the label you are using for training is very different, or is not 100% aligned with the label we really care. And for example, in automatic driving, we really care about how this vehicle reacts to different scenarios. But while training a computer vision model, we normally resort to some commonly obtained tasks or data that allows us to do some low-level understanding, for example, color and shape, or object recognition, checking, instead of going to the higher level on the scenario. It's also because it's much harder to obtain scenario labels comparing with the labels of these of objects or colors or shapes. And similar things happens in AI dialogue. We really want to understand if this dialogue system understand or can communicate on the intent level. But it's much easier to obtain data on the word level understanding. It's much easier to evaluate our model on the sentence level understanding. And so those gaps can sometimes create some misalignment between the customer's anticipation and the machine learning scientists' efforts. So there have been several works talking about this issue, and feel free to go through that if you're interested. And third, I'd like to also mention that machine learning services never ends. So it's very different from a competition that you build a model, you predict the model on a fixed set of testing data, and then that's over, and we compare the results. But while trying to build a model to serve the clients, usually this model has to be sustainable and has to be used repeatedly. Hopefully like 24 hours per day, like 300 days per year, something like that. So we need to care about this. So machine learning as a service is not just about performance. It's more about automation and consistency. So for example, in Appier, we constantly have hundreds or even thousands of machine learning models running at one time, running online. So we are serving more than 1,000 models and assuming more than 1,000 clients, and assuming each client have 3 models, then we will have 3,000 models over there. So that means it's almost impossible to have like a machine learning scientist or engineer to spend too much time on each single model. So we need to automate this process. So the training, the tuning, the parameter search, even like the feature engineering, all kinds of process, it's better to be as automated as possible so we can serve as many clients as possible. And second, we need to be aware of concept drift. So since we are anticipating to allow the model to serve the customer in the long term, so we need to be aware that so it's almost impossible to assume, or it's unrealistic to assume that data will stay unchanged. No concept drift happens. And third, and we need to synchronize the data and model generation time. So we know data are coming continuously through your survey model, and you need to rebuild the model, you need to refine the model, and everything has to be synchronized and in a certain way. And finally, we need to carefully monitor the performance of each online model. So to be aware of some fatal mistakes, so our customer won't complain about that. And so here I'd like to also talk about model complexity versus quality trade-off. So when we train students in the class, we always think about improving the performance, meaning like we want the accuracy, we want F-score to be as high as possible. But while trying to build a machine learning model to serve a lot of clients, we need to care not just about the performance. We need to care about a lot of other things, like how much efforts you need to build this model to achieve certain amount of accuracy, and how much computational resources is required, and how much maintenance and serving efforts are required. So maintenance part, if you are building a very, very sophisticated model and tuning the parameters takes a lot of time. So this probably is not good enough for machine learning as a service because it's much harder to maintain. And we also have to be aware that different clients might require different quality of models. For example, for retail, for e-commerce, and probably people cares about the real-time response. They need the model to be fast, and they need model to adapt to the trend. And they probably don't need a very, very high accurate the model. But in finance, probably the performance is very important. We want high quality to predict, for example, the stocks. And we probably can allow higher complexity on the model because it doesn't really need a real-time response. And so this tells us for different verticals, we might need to balance this triangle. And finally, I'd like to introduce the solutions from Appier to deploy machine learning as a service. So as I mentioned in the early stage, so in the beginning, we need to pay attention to the data acquisition and pre-processing. We need to collect data, clean the data, define the labels, and define probably some pseudo labels, and checking for bias. And then we enter the model training process, and we need to represent the data. And so probably the most popular ones is through deep learning model, trying to generate embedding for models. And we need to make sure the process is as automated as possible. And we also can rely on multitask or transfer learning to learn from different sources of data. And once you have the model ready, so it's not one-time thing. You have to serve, and then you have to make sure your model can be updated based on the results of serving. Okay, and it's also we need some sort of mechanism to detect serious concept drift. So in order to react in advance, and also online bandit algorithms could be very useful for our scenario because it allows us to dynamically select different models for ensemble that allows us to quickly react to the change of the world. Okay, the final remark. So for a B2B2C company like Appier, so we are building machine learning model for our client, and our client use this machine model to serve their customer. So that's what we call B2B2C. Okay, and so providing a sustainable and scalable long-term services to our client is very important. So we are not thinking about just boosting the performance to the very end, but we want to make sure the model is stable, the model is robust, the model can be as dynamic, react to the real world changes as possible. And a machine learning as a service company normally needs 3 types of personnel. So first, we need a machine learning modeling engineer or a scientist. So their goal is to build a high quality machine learning model to make sure the model can achieve a high performance. But besides that, we need some what we call MLOps, the operating engineering machine learning specialist. That those people, they maintain the whole pipeline of the serving and training, and they want to make sure this full cycle of service can operate as smoothly as possible. And third, we need data analysts. So these people, they look into the data and they try to obtain some insights on the data that allows the machine learning engineer or scientist to better monitor the system and better improve the quality of the machine learning engine that's serving online. Okay. So I think I will probably stop here and take questions if there are any. Thank you. Edward, I cannot hear you.
Sorry. I saw there are questions. So can you see the question from the typed text?
One question, right? What are the best strategies to reduce the bias, since it seems hard to get rid of it from understanding of it? Yeah, so so there are several ways depending on what kind of bias you are talking about. So for example, for the online serving bias, okay, and so it's you need to be aware of this serving, the quality of serving, or the login distribution, meaning like how likely this product or item has been shown to the user. And really for this serving bias, it's an explorative problem. So we don't want our serving to only focus on a small set of items or small set of high quality items. We want to explore the rest of the products that has fewer chances to be shown to the users. So if you have this explorative mechanism that allows you to alleviate the effects from this serving bias. And for the other bias, for example, like manual bias, we need to understand that they exist in the very beginning and try to probably avoid them by adding some debiased data. And I think there are also different kinds of algorithms and machine learning models talking about debiasing. And I believe probably in a couple of days in this summer school, there's a speaker talking about fairness in machine learning. They could cover this issue. Okay, and let me see. How can machine learning service apply to finance, like quant trading decision trees? So as I mentioned, for finance, it's different from for example, retail. So in finance, usually we need a high quality of a prediction. Okay, so in this case, you probably need to invest on how we can obtain real-time information from the world in order to fit this into the model. So to predict, for example, to predict the stock value, what happened in the previous hour in the world probably is very important. So if there is a spread of the virus or COVID-19 virus, so they will definitely affect the stock. So for finance, I believe one of the key would be like obtaining as real-time information as possible and fit that into the model. Okay, let me see next. Oh, a lot of them.
Yeah, you have a lot of question list.
Do you host all models yourself, or in some instances, customer also required to run the model? It depends. So depends on which company you are talking about. So, so this question is: do you host all models yourself, or in some instances, the customers also required to run the models in their own their own site? So, if you are using the services like AWS or Google, then you are building your own model. You just use their platform to to host your model. But in Appier, usually our clients, they might not have sufficient background to operate the model, and so we offer this service for them to operate everything for them, including retrain the model, refine the model, and to make sure everything is running smoothly. Okay, next. Machine learning as a service is an interesting idea. Serverless means better user experience for customer comparing to current popular ML product, which needs user to specify compute resources, usually the cloud service. What's the charging strategy for machine learning as a service for Appier? Okay, so I'm not quite sure. I don't understand you if the charging strategy means how much we charge our clients. So it's different from like AWS or Google. That's charged by the amount of data you are putting on the space on their cloud, or like the computation cost. So in Appier, our service is including training the model and everything. So it's usually a negotiation phase to talk about what our clients want us to do, and we offer a price quote, and it starts from there. Okay. I think the fairness of a train model is a big concern this day in industry. How do you handle this? Okay, so I will leave this fairness question to the I think next sections. I believe we have a full section talking about fairness. And so stay tuned. Does it work well with computer vision problem? Of course. So it's work. Machine learning as a service depends on what kind of services you are talking about. But supposedly it doesn't matter if it's vision or if it's NLP or if it's finance. Once you need a machine learning model to operate continuous service, then you need this kind of framework. How do you monitor if customer data privacy is an issue? Okay, and that's a quite that's a good question. So client's privacy depends on. So I think people all know that privacy is one of the most talk concern in recent years. Like Apple, they have released this iOS to avoid people using their client's data in an inappropriate way. So the best way is to obtain the client's consensus that their online data will be used to better serve them, and if they agree, if they click this agree button, then we will use their data. Otherwise, we won't. And normally, for Appier, company like Appier, the clients provide us their data, their their first party data. So we don't really, because the clients have their first hand contact with their customers, and we serve for our clients. So the privacy is less like critical for a company like us. How do you handle? What resources are there for training ML ops? So it's a very good one, but there's no short answer. You need to practice, and a lot of hands-on works and hands-on experience is required for ML ops. So it's harder to train it from school unless you have this opportunity to really build a model to serve your clients in the long term. Otherwise, I would suggest probably learn it from experience. Okay, so I will probably won't be able to take all this. I will selectively choose some of the question to answer. How do you handle adversarial attack in real world? So this is another big question. So, and just like everybody else, if there's adversarial attacks, then we probably need to build a defense algorithm to do that. What are the tools and metrics to measure the bias? This is a good one. What are metrics and tools to measure bias and data quality issues? So it's there's no, as far as I know, there's no this like standard tools or metrics to really measure the data bias. So usually, and sometimes we don't know how the data are obtained by our clients. So normally in practice, what we do is if we find there's a gap between serving quality and the training quality, that probably implies the distribution of the serving data is different from the distribution of the training data. So we always check that. And once we found the distribution are very different, then we need to be aware of potential biases. What are main machine learning service in Appier? Recommend image finance, how to transfer skill experience of a technique to another. So the main machine learning services in Appier is that we use a prediction model. So any kinds of tasks that can be described as a prediction or as a segmentation or classification can be modeled in Appier's machine learning framework. So including recommendation, image search, of course, finance prediction, user segmentation, all kinds of tasks we are able to model. So from the technology point of view, so it's all about mapping this into a suitable techniques that can be solved by machine learning models. We know there are a lot of machine learning models, and along this line, in this summer school, you will learn a lot of them. And then the next step is how can you master different set of skills in machine learning, and once you face a real problem and find a suitable solutions to build a model for it. Oh, by the way, just an advertisement, I will be talking about something relevant to this in August 19th. And there's a section here. I'm going to share some of the practical experience in how to build a machine learning model to satisfy the client's need. Okay. Can you briefly explain the current tech stack at Appier? Are they based on open source in-house products? Okay, so of course, we are using open sources, and we are also building our own machine learning models. So it's a mix of things. So we are not creating things from scratch, of course, but a lot of scenarios we we found the existing off-the-shelf solution doesn't fit, can help us solve the problems we occur that we need to build our own. What is the biggest challenge for machine learning as the service company to become profitable? Okay, this is a good one. So I would say that to build this kind of service, it requires a lot of efforts in the very beginning. As I said, everything has to be automated, and you need to build this monitor. You need to all kinds of infrastructure, all kinds of mechanisms to make sure you can serve a lot of clients in a continuous manner. Okay, and once you have this infra framework, and you have a very good SOP to create models for the clients, then things can speed up very quickly. So if you can handle 1,000 clients at one time, and as opposed to only 100 clients at one time, then you know like how much profit comparing 1,000 to 100 clients. So it's all about scalability, not scalability in terms of the number of data, scalability in terms of number of clients, the number of models you can handle at one time. If you can serve thousands of clients at one time, and which also requires minimum effort from your clients, then the clients will be very happy about it. They will introduce new clients to us, and then they will make a company profitable. Okay. How could we avoid bias? Okay, so for the bias issues, I will refer to the future section. And how can a team avoid manual bias? Again, how Appier attract new customer or face the competition of other company? So this is a good one. So I will offer my own opinion. So it's not necessarily represent the whole company. But so for me, I think the key is really going into fundamental first. If you can achieve high performance in the task the clients really wants. For example, if the client wants you to predict which customer will purchase a specific set of items, and they want to build they want to send emails to attract those customers for purchasing, then you want to maximize the purchase as much as possible. So all the clients look at the number. That number is the profit they gain after they use your service. Okay, so that's the first thing. But that's not the only thing. So if you need, as a company, if you need to spend a lot of efforts to satisfy one client, then that's not enough. That's the main thing of this whole talk. We need to use very limited amount of effort to serve as many customers or clients as possible. So for example, Appier has 1,000 clients, and each client probably they have 1 million customers. So that means 1,000 times 1 million. We are indirectly serving this many customers. So you want to make sure this whole infra and this whole process requires minimum efforts. We are not able to hire several thousands of people like Google and other big companies. So we have 500 people, and of course, none of them are machine learning specialists. So we have only a handful of people, and they have to be responsible for this many clients. And how can we do that? That's always a very challenging but very interesting task we need to solve in a machine learning as a service company. Okay.
So
I think
I think we have over time. So you have the following schedule. So very appreciate for Professor Lin's sharing. So finally, I would like to ask for all the students. So because you have a rich experience in either in the academic research and also in industry. So maybe you can give like a very simple recommendation or suggestion to all the students how to gap between the academic research and the industrial need.
yeah, so get your hands dirty. So try to handle real world problem as early as possible. And so you know you know what the real world is really like. And then once it's your time to go into industry to look for a job, you will be more ready than others.
Yeah, thank you. Thank you. So yeah. So if for the older student you still want to know more, we have a full lecture at the August 19th morning Taiwan time. So you can continue to learn from Professor Lin more. So thank you.
Thank you.
Thank you. Bye-bye.